Okay, anyone here used Git before? GitHub or GitLab or uh, Bitbucket or okay, great. So today, including the in-class exercise, we will teach you how to use GitHub actually, which is one of the most popular, I think, right now, um, version control system. And what do I mean by version control system? I'm gonna first motivate why you should care about this lecture, right? I think this is generally a good idea, like motivating why you should actually learn these tools, right? So let's switch gear a little bit and imagine this. Let's say you're working on a group project and you spend 7 days cramming code in, right? I think we are all in that situation before sometime in our life, right? If this is like your first semester ever, then imagine this happen. And you finally get everything to work and planning to do a pilot run so that you can actually submit your assignments. So you create a directory to store the results, and you instead of creating a directory because you are sleep deprived, right? I think we are all in a situation where there's a deadline coming in and you haven't got sleep, so you work toward the deadline and you figure, hey, after the deadline passed, that's when I'm gonna sleep, right? So you make a typo, which is also something possible, and you type in rm-rf start. What will happen next? Yeah, everything is going to get removed, right, from this current directory, which means that your 7 days worth of code is gone, right? So what should be your response? Cry. Yes, I think that's a perfect response to what just happened, right? And you don't want this to happen because sometimes you don't even have backups, right? Unless you archive this before somewhere else, rm-rf will actually get rid of everything. So rip, right? For sure, rest in peace and cry. And that's a bad thing. So let's actually use a tool to make sure this doesn't happen or decrease the likelihood from this to happen. Imagine the second scenario. You work on a group project again, right? Same setup, working on a group project. This is going to be kind of your life from now on. Sorry for laughing, but yeah, it's gonna be your life from now on. You're gonna be working in a team, even though when you go to the IT, like a big tech company, right? You're gonna work in a team. You're gonna develop part of the code, and sometime you run into bugs. Right? Anyone here never run into bugs on your code before? Can you raise your hand? Who here hate bugs in the code? I think we all do, right? We all hate bugs. Um, some of us, like myself, I hate bugs in reality too. But we all don't like when there's a bug on your code, and the safe thing that you have to do is actually get rid of it, right? To make sure your program behave accordingly. So let's say you have one bug, and you change the code, and with that changes, you get rid of that bug, but created three more bugs, right? And to get rid of the three more bugs that you just created, you ended up creating 10 different bugs on the code. What should you do here? So, what would you do? Undo, right? Well, you try to undo, but sometimes you cannot undo. Let's say you save the file, you open another file, sometimes you cannot undo. So, go to sleep is definitely a legit option. Give up, go to sleep. Uh, Go back to the previous archive. That's a great answer, right? So rather than sitting silently in a corner, um, thinking about all your past life choices and wishing that you can revert back to the old version with one bug, right? Or at least you can compare the two versions. You might want to be able to archive them, right? So that you don't become sad. So these are the general scenario, and from let's actually tie that a little bit more to, and yes, sit in a corner and rethink your life choices. I think you're too young for that, so let's let's not do that. I'm saying that as a joke. So yeah, don't do that. You guys are doing great, and I think the science division, especially the CS program here, is definitely one of the best. Well, I mean, I'm a part-time lecturer anyway, so I've seen multiple university CS program, and I can definitely say this is one of the best. At least comparing to the place I've been teaching so far, right? So don't sit in a corner and rethink life choices. Go forward and tackle the problem, like assignment one, then our in-class exercise. Yay! Um, so generally, if I want to tie this to something more familiar to all of you, I guess, is like, let's say you submit the code and you're like, hey, why doesn't it work? I thought it kind of worked yesterday. I don't know what happened. And you told me that. Or you can tell me I should have deleted and rewritten my code, or maybe I should have just delete everything and rewrite my code from the get-go, right? Uh, depending on the situation, sometimes your code is a mess. You might want to, but now that you have the knowledge of like the algorithm and the implementation a little bit more, sometimes you just want to delete everything and re-implement the code, right? Sometimes you might just run into a situation where your computer crash and you lose all your work. Does this happen to anyone here before? It definitely happened to me, right? Also, thanks to the super reliable electrical system, which I guess I'm just basically now complaining about uh, Thailand in general. Sometimes your power goes off, right? And yeah, it's like someone delete my code because I haven't really saved my code, right? And for those who say thankfully not yet, awesome. That's a really 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 good thing to a great streak to happen for sure. I work with my friends and he accidentally deleted my code. Or I work with my friends, he modified my code. I don't know what he did, but he went to sleep. I think that happened before. At least that happened to me before. I was like, yeah, I cannot contact you. Can you get me back? What did you write here? I don't really know what you're trying to do here. Right? That fast again. These are common problems, especially in your university life, right? So when you graduate, it's gonna be more of the okay, I want to have version control kind of thing. Yes, the intercept. Yes, that can definitely happen, right? So version control can come to the rescue. This is where you can deploy techniques to have different version of your code. So let me ask you this: what's the most primitive form of version control? So let's say I don't give you any tools, right? Just Linux. If you want to do version control, what you might try? And to be honest, I did try this before I learned how to use version control back in the day. How many people keep the old version of your code just in case you created more bugs in the new version? How many people have done that? Yeah, multiple save file, right? So for those of you who keep multiple save file, how many of you run into the situation? I have to revert back, and I don't know which one do I start with. Or just rewrite the whole thing. That's a that's a little bit too much effort for my test, but a lot of people choose that as well, right? Mm, before Git, yeah, definitely before Git. In that case, you can maintain multiple versions of the file, right? And that's not really optimal because at the end of the day, you can get confused. Like, I want to go back to this change on this line, where this line still have this for loop rather than the while loop, right? Which version has that? I might forget, right? So here's the tools that you can use. It's called version control system. It allows you to track all the changes, which sounds awesome, right? we are not going to dive into how they implement this version control system and track all the changes without exploding your hard drive. Because if you're going to keep a copy of the file everywhere, you eventually will run out of hard disk space, right? So it track the changes and it allow you to go back in time. It allow you to go back in time systematically so that when you accidentally delete everything, I guess for the most part, you can revert back, right, to the earlier version before the deletion happened. It also can keep track of everyone's contribution to the changes. Why is that good? Imagine, let's say you're in a big tech company, right, where there are multiple teams working on different part of the same code. Imagine your code is like 1 gigabyte in size, right? Imagine how many files would be in there. Which means there are multiple teams working on different parts of the code or the products that you're working on. So if you want to change someone else's code, you know who make the original code, so that if you have question, you can contact these people, right? It would have contact information, so you can actually maybe email the person who write the code and actually modify it correctly without creating more bugs, right? So there are multiple version of a multiple program that are or version control systems that are being developed, right? If you're in the older, like my generation, for example, Subversion is basically one of the popular choices. These days, I think no one here never heard of Git. Anyone here never heard of this thing before? Git. Oh, sorry. Anyone here never heard of Git? So if you have heard of Git, great. This is one of the tools that we're gonna use for this class, and it's gonna be one of the common tools going forward whenever you get employed, right? These software can change over time. Git is really, really good, but who knows, in the next 10 years, there might be a better software coming out, right? Mercurial is another popular software. When I was interning at several company in the past, right? They actually use Mercurial to maintain their do their version control for their software. So if you see the command that starts with Git, you can guess it's probably use the Git, right? Git as a backbone. If you see the command that use HG, it's probably Mercurial. Anyone want to guess why? Was HG command for Mercurial. Yeah, it's the if you go look at periodic table, right? HG stands for Mercury, so that's actually where the command name come from. And with this, right, you have multiple software, and one of the property of this VCS or version control system is you can actually make it distributed. Whenever I said the word distributed, or whenever someone said the word distributed, it means that it's everywhere. It's a system that being applied at multiple locations, right? So with the distributed version control system, what does it really mean for example, with GitHub, right? Is you can have the local machine that contain the local copy. And you can maintain multiple copies on multiple machines, which means that you can edit your code locally on your own machine. And you don't have to talk to the central server when you edit this file, right? And you only synchronize with the central server once in a while to say, hey, I'm done with this file, here's a new version. I'm done with this file, here's a new version. And a good balance, this basically gives you a good balance of collaboration and working independently. So why is that good? Anyone can anyone explain why is this a good properties to have in a version control system software? So imagine this scenario, right? You have a server that hosts some code, right? Then you can actually maintain this code on your machine A, and someone else can have the same code, right, on machine B. This is going to be version 2, this is going to be version 3. And then when you want to push the change to the server, it basically can be the updated version where you have version 2 and version 3 combined and see all the changes, right? So that's why you can collaborate and work together in a big team where everyone can program on your own computer, right? Because otherwise this can get annoying. Anyone work on a group project and you ended up like cluttering in one single computer before, like because you have to develop on one computer, so 5 people basically looking at that monitor trying to figure out how to code that part. Anyone run into that situation before? Yes, no. There's a long pause. Sorry about that, guys. Yeah, I'm so sorry. Yeah, I forgot that we are all doing things online since COVID. I should not have reminded everyone of that. But okay, let's look back at the prehistoric time before we had this pandemic and um the time when we can meet people or human. Sometime you can develop code like have a pair programming where someone would be like on a computer, like basically 2 people on the same computer trying to figure out how to code that part. Sometimes it's a good thing, sometimes it's a bad thing. When it's a bad thing, it can be annoying because the other person doesn't have access to the keyboard. They cannot really develop code in parallel. Git and distributed version control system would help addressing this problem. So today we will get into how to use Git, right? Which is one of the most popular distributed version control system. The benefit of Git is it gives you easy way to branch the code out and also easy way to merge the code back. It gives you a flexible workflow. It checks for data integrity, so the file would not be randomly corrupt. And it's really fast. It's actually really fast. So it's high performance as well. So today we will learn how to use this seemingly useful tools. The first thing I'm gonna have to introduce the new terminology called repository or repo, right? Sometimes you heard of the word repo before. It stands for repository. It's basically a collection of file and directory and all the version history, and the history would appear in a snapshot, right? Think of a snapshot as when you're watching a video and when you want to take a snapshot, basically you're taking one picture from the video, right? So your repository would kind of work over time like that continuous video, right? And then the snapshot is the instance of each timestamp that happens. And this snapshot, another analogy is like when you play a game, right? You can save in the game and you can load that snapshot later. Right? You can load the snapshot later. Same concepts. This is called commit. It's called a commit. And a repository can have different branches, each with their own history of development. Basically, each branch can work separately, and then you can merge them back later. And now I'm gonna draw over here to kind of like visualize how it works, right? So let's say this is the oldest version of your code, and this is the most recent version. Originally, there are 3 files. I'll call this file A version 1, B version 1, and C version 1, right? It's a version 1 of each file. Then you modified file A into version 2, and file C into version 2. And at this point, when you commit into the second version, file B is still version 1, right? This allows you to have two versions where the second version includes the modification to file A and file C. Then you modify file C again and commit, which means now the file C would have version 3, B is still at version 1, A is still at version 2. Then you modify file A, right? When you modify file A, you have file A version 3, file B now also has modification, so it's moved to version 2 and C is still version 3. You commit. Now version 4 would maintain the third version of file A, the second version of file B, and the third version of file C. Then you modify file B again, you have the third version of file B and the the fourth version of file C, right? And now file A is still in the third version. That's version 5. And the version control system allows you to go back in time and pick each version of the file according to your demand. It allows you to pick each file, the version that you demand them to be. So you can kind of like hand you and say, hey, I want file B version 1, file C version 4. That's also possible, right? Which is really useful. So let's actually look at the command and how to use Git. The first thing that I have to tell you is called init, right? Init typically stands for initialization or basically when you call Git init, this initialize a new Git repository. It initializes a new Git repository. And this is done by when you call this command, it would create a hidden directory called .git. The .git directory would contain all the metadata that are related to the current repository. Whenever I say the word metadata, is the data that's tied to the structure, right? It's meta data. Essentially, it's the data that's tied to this particular Git repository. And you can basically use it to basically verify, hey, where are the different versions? What's the server name? What's the repo name and things like that? What are the different branches name? Unless there's someone already create, right, a repository for you to use, for example, on GitHub, right? One thing you can do is you can clone that repository on your own machine, right? So you can choose a remote repository and clone that to your location. The command is called git clone followed by the repository name. If it's on your own machine, you will actually go to the directory that contains the repo. If it's on a remote server like GitHub, then it would have the HTTP address, or you can use SSH as well. There are multiple protocols you can use, but it actually would revolve around the git clone command. So the high level explanation of how you can maintain different versions is this. I'm going to define 3 more things: head, index, and the working directory. Head is basically the last commit, the last versioning that you stamp that take the snapshot, right? So head is already snapshot. It's the save point. If you compare this to a game, it's a save point. Index is the point that are typically in the future. This is the proposed next commit. Basically, it's a proposal that say, hey, maybe we should save the game here, but you haven't saved the game yet. It's the proposed next commit snapshot. Then you have the working directory, which is where we are right now. Some of the files are not even tracked. Some of the files are not even staged inside the index. It's where we are right now. We are modifying code right now. It's not in the index, not in the head. That's called the working directory. And that's why it's named working directory, because you're still working on it. Head is the latest snapshot. Index is the proposed next snapshot. So there are multiple steps behind dealing with these 3 stages. the first stage, which is the head, second stage, which is the index, and the third stage, which is the working directory. So let's say you have file A, and you do some modification on the working directory, and we call this file A version 2. And let's say you think this is a good version, I want to actually stage the commit. We call this stage a commit, all right? Basically propose that maybe we should save the game here. We haven't saved the game yet. We will do this by the command git add. Git add would move file A to index. And the file A version 2 would replace file A version 1 in the index. And if you now think that, hey, that's a good change, let me save it, let me commit this. You run the command git commit with the -m. Git commit -m is tied with the message. This allows you to tell everyone else that share this repository to say, hey, these are the changes I did. And here are the comments on the comment. You can comment, you can provide a comment. And definitely please provide that because it will tell everyone else what you're trying to do here. What happened here is once you run this command, file A version 2 would move to the head, replace file A version 1. It replaced file A version 1. And now let's say you realize that version 2 has a bug, right? Version 2 has a bug. So instead of committing to the head, you want to revert back, right? You want to revert back or unstage the change. You can unstage a change by the command git reset. Git reset, basically, it doesn't really move file A version 2 anywhere, but it replaces file A with version 1. Basically, it reset back to the head version. Unstage a change when you do git reset. Move the file in the head to the index. It's like loading the save point. And you can discard the change completely by reset --hard. This is a hard reset. It would get rid of file A version 2, replace your working directory with file A version 1. Right? So right now we have the three commands. Git add, git commit, and then git reset. Reset has a soft reset where we just throw it away from the index or the staging area, or the hard reset where we throw away that file completely. Commit basically means we commit from the index to the head. Add means we move from working directory to index. You can check the status of the repository using git status. When you type in git status, it would print out, right, information that are related things that, for example, this has not been commit. This is basically now in the index, right? So this is stage, but not commit. And it would also say, hey, this file is modified, right? It's not stage. So if you want to stage the file, you can do git add and then the file. Sorry. Store the file in the index. You can also get the information on any untracked file. These untracked files are not in the repository. If you want to add them to the repository, you use git add again and the file name. It would basically add this file to the repository. So git status would tell you what's going on with the file in this particular repo, right? The second thing that I have to tell you, which is the features of Git, is you can branch out. Imagine you have to develop code for Google or Apple, right, or a big tech company, right? They are likely to have a code that everyone sees and is working. We call this a master. The master branch is the branch that you get when you clone. But inside the repo, there can be multiple versions of the code. Some of them might be having this different features built in that have different features built in. You can basically switch between each. So let's say you are here. Let's say you are right here. You can switch from here to here, switch from here to here, from here to here, from here to here. You can switch to any of these nodes. Some of the node will be on the same branch. Some of the node will be on a different branch. So let's talk about what if I want to switch branch from master to the branch little feature, right? So to switch a branch, right? Let's say the head is at master. You can go to the master branch by the command git checkout master. Git checkout master basically put you at the master branch at the head location. Head is like the latest comment. Then you can switch to branch number one, right? By calling the command git checkout branch one. This would basically switch from master to branch number one. Your code would go to whatever branch one is reflecting at. The version of all the file in the repo would change to the status of branch one, not master anymore. You can also add -b and then specify the branch name as well. In this case, we switch to branch two, and you can basically interchange the code, right, and switch to each of these branch based on the command you put in. The file will be modified automatically to reflect the most updated version of each branch. For example, let's visualize this. When you type checking out master, right, you are going to be here, the blue part. When you do git checkout master, you will be at the master branch. Master branch is kind of like a keyword where you basically master branch means that's the central branch that everyone typically start from. Then let's say you want to switch from master branch to the branch called some features, which is this node, right? You will type in git checkout some feature, git checkout some features. You basically now switch from here to here. Your code would be reflected accordingly based on the changes in the some feature branches. Right? Any questions so far? Any questions so far on how to use Git? So basically, you can maintain multiple versions: version 1, version 2, version 3, version 4. -b is a branch name. Basically, when you add -b, is tied to the name of the branch that you want to switch to. So the checkout command would give you a different branch, right, based on your command's arguments. So if you want to switch from master to some features, just add that -b in the branch name. The head tells you, yes, it tells you where you are at. It actually, when you do git status, it will tell you the status and the branch you are at, so you can keep track of where you are. It will keep track of where you are. And before we leave the lecture portion today, I'm going to show a few things on GitHub so that you can kind of check out the nice user interface that GitHub provides to you, because it's kind of help you visualize what are the different branches, what are the history for each of the branches. All right. So the next thing is, what if you have a server, right? What if the server hosts the master branch and you can clone that? When you clone it, right? When you clone it, basically you have this on your own computer. And one thing you can do is, oh, okay. Yes, -b create a new branch. So when you're on your own computer, one thing you can do is you can have the the branch that are master, right? And then you can work on your own code so that it's fork out two branches. One is called develop branch, and the other one is another develop branch that adds some features, right? Can someone tell me what's the benefit of having multiple branches, but maintain the master branches that are older? So what's the benefit of having these multiple branches? Yes, the master branch is typically the most stable version. And then whenever you're developing your code, sometimes you have bugs, right? So until you finish that, you don't merge it back or move the master. In this case, you can actually move the master once things are done, and you can merge it back to the new master branch after you finish developing the code, right? And when you want to work with a remote repository, like when in this case, when you have a server, right? There are new commands that you have to do. It's called push and pull, right? So when you have to pull from the remote repository, just type in git pull. Git pull will pull the head master at the remote location, update the code in the local repo according to the new update from the server. And here's the overview, right? Here's the overview. Let's say that the local location you are right here, and someone makes changes. Someone makes changes and commit to the server. And now the updated location is this. When you call git pull, basically you move from here to here, as you can see right here, right? Basically, if someone make updates on a server, you want to pull the changes into your own local repo so that you see the most recent changes. The next thing is, what if you have new updates and want you to push, right? Push to the server. So git push is something like this. Let's say you are here, right? And the server is right here. This is you, server. You want to basically push so that the server are at the same location as you. So you just do git push, git push. So that's actually all for the command that you are likely to have to use, right? And here are the workflow summary. You have the remote location. This is the server. This is your machine. And your machine has three things. This is the head. This is the index. And this is the workspace. Like this is working directory. Working directory is the code that you see. Staging is when you stage a change by running git add. You can then commit, right? Take a snapshot of this state change and put that in the head by the command git commit. You can kind of like from the working directory, the files you changed so far, fast forward to just local repo, like basically update the head right away without staging by the command git commit dash a. Git commit dash a would kind of like do the git add and git commit at the same time. You can revert back by using git reset. If you are at the head, right, and you want to update the head to the server, you do git push. If you do git pull will basically move data from here down to here. If you want to just pull and update the head, right, without update the working directory, you can do git fetch. And you can do git diff to see what's the difference between my working directory and indexed. You can do git diff head to see the difference between the working directory and the head. And when you do git clone, as I said earlier, git clone and git pull, basically you're gonna get the most updated version to your to your working directory. Right? So it will bypass all the head or the index down to the working directory from the server. So here's a workflow. But now that I mentioned there are multiple branches, right? There are multiple branches. What if? What if this happened? What if you develop the code with your friends on two different computers, right? And you make some edits, your friends make another edit. And both of you want to push on the repo, right? This basically means that you have two versions. This is basically what happened, right? You, version 1.1, friend, version 1.2. Want to modify the file in the repo together. Just say this is a text file, right? Or your code, your program. And let's say your changes between this line and this line. This is your change. And your friend's changes are between this line and this line. Can someone tell me what will happen if I have to merge these two? You're gonna have a Git conflict, merge conflict, right? This is called the merge conflict. So let's look at how to merge first, right? There are two versions of merging. One way to merge is, let's say there's no branch, right? Let's say there's no branch. When you merge, basically this is called fast forward. Fast forward is basically this where you are. You merge your change and fast forward to the most updated location. The other type of merging is when you are merging two branches. Let's say you have branch one and this is master. You want to merge branch one to master like this. This is also called the Git merge three-way. You collapse the branch, merge into master. All right. And to merge, if the file, let's say this is your file, right? And this is where you make edits. This is where your friends make edits. Is there any problems? There's no shared lines of the edits to the file. Is that a problem? So if this happens, Git will merge for you automatically. But if your file happen to be something like this is a file, you make the edit over here. And as I said earlier, your friends make an edit over here. There are some shared lines, right? There are some shared edits. So this means that you need to resolve the conflict. And the way you resolve the conflict is whoever commit last or commit later, they have to figure out, okay, with this two version of the file, what do you want in the merge? Git will actually open a text editor where you can check which part and which line has the conflict and which version do you want as a result. You can pick the versions you want, you can pick the file that you want, or you can manually modify the lines that has conflicts. All right, so basically Git would allow you to do that. So here are the kind of like a summary of the command. As I said earlier, init is initialize a repository. Clone is cloning a repository. You can get the status by git status. You can get the log of all the change by git log. Git add will add things to the staging area. Git commit would move from the staging area to head, which is moving the change to the local repo. Push would push from the local remote repo. Pull would pull information or changes from the remote repository to your machine. Git checkout will check out the specific version of the file. Git checkout -b would basically create a new branch. name so that you can check out that branch later. All right. That's all we have in class 5 for you to finish. Basically, this allows you to create your repo on GitHub. This is like an exercise that if you haven't used GitHub before, you can play around with it. If you use GitHub before, I think it's a good refresher for you, and it should take like less than 5 minutes to finish everything. But if you have not used GitHub before, Discord session is definitely designed for this. But before we leave, I want to show you a few things. Do you see the GitHub windows here? Okay, so this is what you would see when you log into GitHub. Let's say I have my own GitHub account, and what I will see when I log in is on the left side, I'm gonna see all the repository where I'm a part of. Some of them are private. For example, this is our project that we haven't published yet, right? So we have a private repository that essentially this one do graph processing. I'm working with one of my master students to basically accelerate graph processing and do some analysis on the algorithm. So in here, if I go to the private repository, you see code structure inside this repository. It has right now 3 folders. Each one of them would contain different code, right? Over here, you can see the script that my student is developing. You can see this file. You click on it, you see the content of the file. On top of it, you see this history. So on GitHub, it actually have an interface that you can check the history of the file. So you can see there's the a change 13 days ago. There's another change 22 days ago. You can even look at this file with this version. It will show the older version of the file, and you might have realized actually much shorter because that's the older file, right? You can then go back and look at this. This is the version for that particular version of the history. You can check out this version. It would reword the repository back to this version. So you can go check the commit ID. This is the ID that's generated by Git that you can go back to. This is so I think this repo only have one person working on it. So let me go back to something else. So if I go to this, this used to be one of the assignments that we asked you to do. I took it out from assignment 1 because I kind of changed it to in-class exercise, and I'm not really asking you to push the change to this repo. But one of the things we ask you to do here is to create a test case for one of the question and push it to the repository right here for assignment 1. You can see that multiple contributor, right? These are basically your friends or your upperclassmen who took this class before and push code here into this repo. So if you look at the commit history, you can see that there are multiple people that provide their own file, right? Each one of them will have its own version. And this is how you can share code online, right? Using GitHub or Git Repo in general. There are multiple public Git repositories that you can use. There's GitHub, there's GitLab, there's also Bitbucket. Most people right now use GitHub or GitLab, right? And our in-class exercise is designed for you to actually get started with this. I am sure you have to use this in the future when you actually get well, whenever you actually work in a job market, right? Okay, any questions before we move on to Discord session and in class 5?